Okay, so guys, in this video we have to study a very important thing known as the Taylor series. Okay, so before studying the Taylor series, I want to recall a very important formula which says that if you are taking the derivative of a function which is having an exponent, so you will basically separate n and then the x will be as it is, the function actually, and then the power minus 1 and then the derivative of x. Okay, now if we are basically given a function which starts from 0 and goes on to infinity, and this function is actually given as scn x power n, this function can actually be written as c0. Okay, so at c0 the x power n will of course be equal to 0 because x power 0 is equal to 1. Then we can expand, we can put the value of n as 1, so c1 x power 1. Then we can put the value of c2 x power 2, and this thing goes on when we put 3, 4 and 5. So this expansion is really nice, but at some point in life we have to find the value of these constants. So how to find the value of these constants? Now we will use the differentiation for finding the value of these constants present over here. So let's just take a simple function which starts from 0 and goes on till infinity, and this function is actually having a constant cn x minus a n. Of course, the expansion of this function can be written as cn. First of all, we will put the value of n as 0, so c0 x minus a power 0 plus, then the value of n will be equal to 1, so c1 x minus a power 1. Then the value of n will be equal to 2, so c power 2 x minus a 2, and this goes on till infinity. If you want to find the value of c0, c1 and c2, it is actually very simple. Due to this x minus a present over here, this is x minus a, this is x minus a, this is x minus a, it is same, so we can use this notion to find the value of c0, c1 and c2. If somehow we manage to find f of a, see what happens. We have f of a, so this is 0, okay, so x minus a power 0, and if any function having power 0 will be equal to 1, so this is 1 plus c1, let's just put the value of x as a, so a minus a plus c2 a minus a whole squared plus goes on till infinity. So a minus a gives us 0, a minus a gives us 0, 0 multiplied by c1 gives us 0. So these things are cancelled and we are left with c. See how easy it is to find the value of c0. So we found the value of c0 or c0, of course, the first term. Now how can we find the value of c1? Now we will use the differentiation, the concept of differentiation for finding the value of c1. I would like you to take the derivative of fx. So the derivative of fx. The derivative of c0 x minus a will be equal to 0. How? You know c0 is a constant, okay, so it will be separated. Then the derivative of x minus a power 0, of course it is having a power 0, so the derivative would be 0, plus the derivative of c1 x minus a will be, the c1 will be as it is because it is a constant, the derivative won't have any effect on it. The derivative of x minus a power 1 will be simply 1. We know that the derivative of x minus a will be 1 because d by dx x, a is a constant, so the derivative of any constant is 0, derivative of x will be 1. Okay, so we will have c1 then. Now for this one, we can simply write c2 first of all, and then the power will be separated, so the derivative, so we do not have to worry about it. Then the function power minus 1, 2 minus 1 is actually 1, and then the derivative of x minus a, which is again 1, and this thing goes on. You can use powers of 3, 4, okay, I'm not getting into that complexity because it will be difficult to understand, but for now you can take c3 if you want. You can write c3 x minus a power 3 plus dot dot dot. Okay, so if we derive c3 x minus a power 3, first of all the constant as it is, then the power x minus a power minus 1, 3 minus 1 is 2, and then the derivative of x minus a, the thing which is present inside, is 1 plus dot dot dot. Okay, now again I would like you to plug in a just like you did over here. Let's just put in a, so f prime of a would be equal to, so this is 0, this is c1, so c1 is left plus, wherever you put a, this will be a, this will be a minus a is again 0, so this term is cancelled and this term is cancelled, so we have 0 plus 0. Again you see we found c1. In this case we found c, in this case we found c1. We will take the derivative again so that we can find the value of c2. So we know that the derivative will be, so the second derivative of x, so this will be 0 plus, now we found c1, so we do not have to worry about it, so we will just not take that. And the derivative of c2 x minus a power 2 will be, first of all the constant as it is, then the power, then the function x minus a power minus 1, 2 minus 1 is 1, plus the c3 x minus a power 3, So c3, then the power function power minus 1 squared, the derivative of x minus a is 1 dot dot dot. So basically you are taking the second derivative, so x minus a won't be over here, and this will be having only one power. If you were just confused with the mistake I made, just don't worry about it. You just have to look at the previous term. You see c1 was not having any x minus a term, so c2 won't have any x minus a term while we are taking the second derivative. Now again, put in the value of a. So a, you will have 2c2, it does not has the x minus a term, right? But this one has the x minus a term, so this will be 0. So again we have 2c2, we can find c2. Yeah, and we can also derive this formula. So c2 can also be written as f double prime of a divided by 2. We can simply divide the 2 on the both sides. And then we have to derive c3, 3 x minus a power 2. Okay, so if we derive this, 3c3 will be constant, so it will be separated, and then the derivative x minus a will be, the power will be separated, then the function as it is, power minus 1 is 1, so 3 times 2 gives us 6c3 x minus a, and the derivative x minus a is 1. So when we take the second derivative, the derivative of 3c3 x minus a power 2 will be 6c3 x minus a. Now when you take the third derivative with respect to x, we only have 6c3 x minus a, of course. So we can simply derive, and when we will derive, 6c3 will be constants, and x minus a, the derivative of x minus a will be 1. Plus this goes on for the fourth term as well, so you can take the fourth term also. So if we put the value of x as a in the third derivative, we will have 6c3, just like we were having 2 over here. Okay, so now we can see a pattern. First of all, we were having only one power, then we were having c1, and then we are having 2, then we have 6. So we can see a very definite pattern over here. Now we can also derive this thing. We can also write, just like we did it over here, we can write c3 would be equal to f third derivative with respect to a divided by 6. So we can simply divide 6 on both sides. Now one more important thing, instead of writing 6, I can write 3 factorial. Now it's actually very important. You know why? Because when we will be taking the fourth and the fifth and the sixth, you know, this term is actually going on till infinity. So even we will have to take the derivative up to 24 terms, which will be a mess. So instead of writing the numbers, the huge numbers, we can confine them into the concept of factorial. So 3 factorial is actually equal to 3 times 2 times 1, which is equal to 6. Okay. Now you see c3 is actually equal to third derivative with respect to a divided by the third factorial. So what would be c4? c4 can also be written as c4 is equal to f fourth derivative of a divided by fourth factorial. And same thing goes on for c5, the fifth derivative with respect to a divided by the fifth factorial. Now you can see 1, 2, 3, 4, 5. We can replace this 5, 4, 3 to 1 with a number n. So Cn would be equal to f nth derivative. You will take the derivative n times. N is actually equal to 1, 2, 3, any number given to you. So the f nth derivative with respect to a divided by n factorial. Now this thing actually works for all the terms, even the first term. If you see, we just put in the value of 0. Now you have to keep this thing in mind from the beginning. Since we started studying math, we are considering 0 to be nothing. But from now onwards, we will be taking 0 as the first term. So the 0 first term will be f power 0, f 0th derivative with respect to a divided by 0 factorial. So 0 factorial is actually equal to 1, which will be equal to f a. And if you see what was fa, so fa was giving the value of the first term c. So we can write this function f of x as f of a. Okay, so f of a was actually simply c plus what was the value of c1? The value of c1 was f first derivative with respect to x. And what was it? It was this thing. So the first derivative, so the c1 was actually f first derivative of a with respect to 1 factorial. So we can simply write f first derivative with respect to a divided by the first factorial plus f second derivative with respect to a divided by 2 factorial plus f third derivative with respect to a divided by third factorial, and this series goes on, and this thing is actually known as the Taylor series. So now, what is the formula for the Taylor series? The formula for the Taylor series says that if you have f of n, okay, so n is starting from 0 and ending towards infinity, so fn, and you have to take a and n, of course, n factorial divided by n factorial, x minus a. So notice how the n's are changing. You have the first derivative with the first power with the first factorial. You have the second derivative with the second power with the second factorial. Okay, so now let's solve some examples related to Taylor series. So first of all, this is the function, so f of x is actually equal to natural log of 1 plus x. Now let's take the first derivative of this function. So it would be 1 divided by 1 plus x, and the derivative of this thing will be 1. Then the second derivative, so we can reciprocate this thing. So the second derivative would be, the negative one will be separated because it is a power. Then the function power minus 1 minus 1 minus 1 gives us negative 2. Then the third derivative, negative 1 will be separated, and then the derivative of this thing right over here, so minus 1 as it is, then the power, then the function power minus 1 minus 2 minus 1 gives us negative 3. Negative 1 multiplied by negative 2 gives us 2. 1 plus x, negative 3. We know that the value of x is actually 2. So I can put the value of x wherever I'm having x in this function. So first of all, f of 2 will give me log of 1 plus 2, which will be equal to log of 3. Then we have f first derivative of x, basically f first derivative of 2. So it would be 1 divided by 1 plus 2, which would be 1 divided by 1 plus 2 gives us 3. Then the f second derivative of 2 will be f second derivative of 2, negative 1, 1 plus 2, negative 2. So we can write negative 1 divided by 1 plus 2 power 2. Negative 1 divided by 1 plus 2 is 3. 3 square gives us 9. F third derivative of 2 gives us 2. 1 plus x power 3. 2 divided by 1 plus 2 power 3. So it gives us 3 cube is actually 27. Okay, so guys, the Taylor series expansion of this function at x is equal to 2 would be f, the first term, of course, then the first derivative, then the second derivative, then the third derivative. So now let's put all of these values. So the actual function was log of 3, plus the first derivative was 1 divided by 3, then x minus a is 2 divided by first factorial, plus f second derivative with the value 2 is negative 1 divided by 9 x minus 2 square divided by 2 factorial, plus f third derivative with the value 2 is 2 divided by 27. 2 divided by 27, then x minus a power, the value of a is actually 2, then 3 divided by third factorial, and this goes on. So log of 3 plus, let's move the 3 towards the denominator, so we have x minus 2 divided by 3 plus, now let's move this 9 towards the denominator, so we have, so negative sign multiplied by the positive sign gives us negative, so we have x minus 2 square divided by 9 multiplied by 2 factorial is actually 2, 1 factorial is actually 1, 2, 27 can be moved towards the denominator, so 27 divided by 27 multiplied by 3 factorial is actually 3 multiplied by 2 multiplied by 1, which is equal to 6, so multiplied by 6, and we have x minus a whole cube, sorry, 2 whole cube. So we have natural log of 3 plus x minus 2 divided by 3 minus x minus 2 whole square divided by 18 plus 2x minus 2 cube divided by 27 multiplied by 6 gives us, it is actually equal to 162 plus dot dot dot. So you can notice the pattern over here. The pattern over here is actually very specific. We have 3, then we have 18, and then we have 162. So everything is being increased. Okay.